So what we're doing today is we are multiplying and dividing our radicals. So with multiplication and division, it's a little bit different than your add-subtract. Add-subtract, what you would do is you would simplify your radical first and then add your numbers. With your multiplying and dividing, you're going to multiply first. You multiply your coefficients. So those are your numbers in front of the radical. And then you multiply the numbers under the radical, so like your x and your y. And then you simplify. So you're going to actually multiply first and then simplify at the end. So let's take a look at our first example. We have 3 radical 7 times 2 radical 5. So we're going to multiply the numbers in front of the radicals first. So I get a 6. 3 times 2 gives me 6. Multiply the numbers underneath. What's 7 times 5? 35. So then you have to think to yourself, is there a perfect square that goes into 35? Maybe we need to refresh our memories. Miles, put your phone away. Our perfect squares start with 1. 1 squared is 1. What's 2 squared? 3 squared. 4 squared. 5 squared. 6 squared. 7 squared. 8 squared. 9 squared. 10 squared. 11 squared. So be writing your perfect squares on the top of your paper. 196, 225. Go up to the first 15. So do any of those numbers go into 35? 1, but we never actually reduce it if it's only 1. So there's nothing else for us to do there. So we'll leave it as 6 radical 35. Number 2, do you remember what that exponent tells us to do? Multiply it twice. So this is 2 radical 3 times 2 radical 3. If I had an exponent of 3 there, how many times would I write it? 3 times. That exponent tells you how many times to write it. So now the same rules apply. We're going to multiply the numbers in front of the radical. So 2 times 2 gives us a 4. Multiply the numbers under the radical. So 3 times 3 gives us a 9. Can we reduce a radical 9? Yes. What's the square root of 9? 3. So this just turns into 4 times 3, which is 12. Remember, when it's a perfect square, we don't need the 2 radicals because it is a perfect square. It's our goal already of what we're trying to get. All right, so let's try number 3. Multiply the numbers out in front. What do we get? Negative 12. Multiply your numbers underneath. What do we get? 50. Is there a perfect square that goes into 50? 25. So it's going to be 25 and 2. So what's our square root of 25? 5. 2 stays under the radical. And I need to multiply negative 12 times 5. So what's our final answer? Negative 60 radical 2. Yeah, it is. All right, number 4. What are our numbers in front of the radicals here? They're both 1s. So 1 times 1 gives us a 1. So you can write the 1 there, or you don't have to. So multiply underneath 3 times 24. 72. Now 72 is a radical that they love to use constantly because there's lots of perfect squares that go into 72. You've got to find the largest one. 36. 36 times what? 2. Square root of 36 is 6. And then I get my radical 2 afterwards. So 6 radical 2 is our answer. All right, I want you guys to try 5 and 6 right now on your own. Multiply the numbers in front, multiply the numbers underneath, and then reduce. So what's our perfect square that goes into 18? 9. 9 and 2, which comes out as a 3, so 15 radical 2 is your final answer for number 5. Did anybody get that? All right, good job. So again, 6, we had a radical 18, so that's 9 and 2. But then I have to do that 8 times the 3, so I get negative 24 radical 2. Woo, all right. Practice makes perfect. Well, you know why we do it so many times? Because it takes something 17 times of writing it to commit it to memory. Another 15 times, you got it. So another thing they do with their multiplication is they do the distributive property. So we got our parentheses here. So we have to distribute our radical 5 to both things in the parentheses. So we're still doing our multiplication rules. So when I multiply a radical 5 times a 2, the 2 is not under the radical. So I'm not going to multiply those and give myself radical 10. This is going to become 2 radical 5. It's kind of like if I did an x times a 2. You can't really combine them. It just becomes 2x. But then radical 5 times radical 10, those are both underneath the radical sign. So we multiply them and we get radical 50. So now can we reduce a radical 5 at all? No? Can I reduce radical 50? Yeah, what's our perfect square again that goes into 50? 25 and 2. Square root of 25 is 5. I'm going to bring down my subtraction sign and bring down my 2 radical 5 that was in front of it. Now thinking back to last class, can I subtract those? No, they don't have the same number underneath the radical. I got a 5 and a 2. So I can't combine them. That's going to be my answer. Okay, so number 2. Same thing. We're going to distribute. We're going to do this times the first term. So 3 times 2 gives us a 6. Those are both not under the radical. Under the radical, we have a 2 times a 2, which would give us 4. So 6 radical 4 is our first term. Now we're going to multiply it times the radical 6. So again, there's a 1 out here. So 3 times 1 gives us a 3. Multiply underneath 2 times 6 gives us a 12. Let's not simplify both of them. Square root of 4. Is that a perfect square? Yep. So I don't need my 2 radical signs because that's already a perfect square. What is the square root of 4? 2. And I got to multiply it times that 6. So I get a 12. Now for the other one, what's our perfect square that goes into 12? 4. 4 and 3. The 4 comes out of the radical as a 2. When I do it times the 3, we get 6 radical 3. So 12 plus 6 radical 3 will be our final answer there. So multiplication, multiply first, simplify after. Division is always a little bit different because you can get some fractions or decimals and we don't really want those. So with division, you always want to try to actually divide the 2 numbers first. If you can't divide them, then you just want to try to go ahead and simplify them as much as you can. So if I look at the first example, 16 divided by 25. Can I actually divide 16 by 25? I could, but what would we get? Decimal. We don't want a decimal. So what we do is we separate this and create 2 radicals. So we have square root of 16 over the square root of 25. All Are those perfect squares? Yeah. 16 is. What's the square root of 16? 4. What's the square root of 25? 5. So that's our final answer, 4 over 5. Yeah, we'll get to some. So for number 2, can I divide 36 by 256? No, we'll get a decimal again, so I'm going to separate them. Square root of 36 over the square root of 256. Is 36 a perfect square? Yeah, what do we get? How about 256? Well, try it in your calculator first. Square root of 256, let's see if it works. 16. So now can we reduce 6 over 16? Yeah, what can we divide them both by? Not 3, 2. So we would get 3 over 8. That would be our answer for that one. All right, number 3. Can I divide 48 by 6? Yeah, what do we get? 8. Now, since 48 and 6 are both under the radical, the 8 is also under the radical when you divide. So now we have to ask ourselves, can we reduce a radical 8? Yeah, what's our perfect square that goes into 8? So 4 and 2. 4 comes out as a 2. And then you still have that other 2 under the radical, so 2 radical 2 is our answer. All right, 12 and 27. Can I divide those? No. So I'm going to separate them. Now, are either of those perfect squares? No. So, we're going to do what we normally do when they're not perfect squares. Set up your 2 radical signs. What's our perfect square that goes into 12? So 4 and 3. What's our perfect square that goes into 27? 9 and 3. Now, do you see how they both have a radical 3 here? That cancels itself out. Radical 3 divided by radical 3 cancels it out and it's gone. So now what we're left with is, what's the square root of 4? 2. And what's the square root of 9? 3. So there's our final answer. 2/3. I know. Mind blown. All right, number 5. Let's try to divide first. Can I divide negative 20 by 4? Yep. Yes. When I do, I get a negative 5. Can I divide 6 by 2? Yes. I'd get a radical 3. And we can't reduce a radical 3 any further, so that's our final answer. So number 6. Can I divide 15 by 3? Yes. I'd get a 5. Can I divide 11 by 49? No. But 49, that's a special one. That's a perfect square. What is the square root of 49? So I would have 5 radical 11 in the top, because when I divided my 15 by 3, I got 5. And then 7 stays in your denominator since radical 49 was down there. All right, our last row here. Can we divide 10 by 5? 2. Yep, so we get radical 2. We're going to go ahead and skip number 8. So we're left with one more. Can we divide 3 by 12? No. So I'm going to separate them. Radical 3 over radical 12. Neither of those are perfect squares. But I can't break down radical 3 any further, so that's going to stay as a radical 3. What's the perfect square that goes into 12? 4. So again, what happens with our radical 3's there? They cancel each other out. Now, I can't have nothing up here, so I have a 1 in the numerator. And what's the square root of 4? 2. So that reduces to 1/2.